All right, last time we were working in section 3.1, Numeration Systems, and we've actually moved to the bases at the very end of this section and talking about base addition, subtraction, multiplication, so forth. And conversions is where we're actually working at the moment. And what we're going to take a look at is this example about finding numbers before and after a certain value in certain bases. So this one asks us to find the preceding and the succeeding value to the values 1, 4, base 5 and T, 0, 0, base 12. So that's actually where we're going to start here. All right, so taking a look at the value 1, 4, what is the number that is preceding, that comes before 1, 4, base 5? That's the easy one. What do you think? What comes before 1, 4? 1, 3. 1, 3, base 5. So we just take away 1 from the ones place. Okay, now if we were doing our base 10 system and we had the number 1, 4, we would have 14. What would come after 14? 15. There's a problem with that in base 5. What's the problem with 15 in base 5? There's no 5s in base 5. So I can't have a 5, which means the 1, 4 is as big as I can get in a 2-digit number that starts with 1, right? So what do I have to do to get the next value? I would have to change the 1 to a 2. So the preceding is this one, and the succeeding, the one that comes after it, would be 2, 0, base 5. I've simply run out of digits, right? What happens when I run out of digits in base 10? Well, that would look like the number 19. Well, what comes after 19? 20, 2, 0. So we do the same thing. All right, take a look at part B. One of the values is easy. One of the values is tricky. Which value is easy? Is it the preceding number or the succeeding number? Is it easier to find the number after T00 or the number before? After. Okay? So if you don't like the T, just pretend like it says 100. Okay? 100 for a moment. 100. What's the number that comes after 100? 101. All you have to do is to change the last digit one higher, right? When you're looking at numbers that come before or after digits, it always affects the ones place. That's where you look first. So the succeeding number would be T01, base 12. This is the number that would come after T00, T01. Okay, let's again think back to what happens with the number 100. You have the number 100. And if you want to find the number before it, you can't just change the last digit, right? It changes everything, doesn't it? So the same thing's going to happen here. So let's think about it in base 10 so that we can kind of see what's happening in base 12, in this case, with the number 100. So if we were trying to find the number before it, what happens to the number 0? And what does it really become? What's the number before 100? 99. Good. All right, let's write that down, and then we'll talk about it from that point. Okay, so the 0 at the end becomes a 9, right? 9's the biggest digit in base 10. Agreed? Okay. The number also before it, the 0, becomes a 9. And then what happened to the first value? It went away. It went to 0, right? What if the value had been, let's say, 700 for a moment? What would that number be here? A 6. So the number goes down by 1, right? So the reason the 100, the number 1 went away is because it went down to 0, kind of like what Amanda said. But it would just go down 1 no matter what it was actually before. So let's think through that that's exactly what's going to happen with T00. The zeros at the end are going to become the largest value in that place system. What is the largest value in base 12? It's 11. And how do we write 11? We talked about it last time, but I know it's been a while. We wrote it as E. They wrote it as E. So we're going to write E as our last digit. This is 12 down here. I'll go ahead and put that in. So the very last digit here has to become the biggest value in the place system, just like down here, 0 became a 9, right? It's the one right before it. So what happens to the second 0? It becomes an E as well. And then what happens to the T? It needs to go down 1. What does T mean? It means 10. So 1 down from 10 would be 9. So this is 9EE base 12. All right. What you're really doing is you're borrowing, right? It's like you're borrowing from one bigger. You know, this is what you have to do if you have to subtract and don't have what you've got the values of to subtract it, is you just sort of a borrowing thing where everything becomes the value that's one smaller than it was before, right? And that's what you're doing to take a look at this. It's a little awkward, I agree, but any questions on this one before I move to the next one? Okay. So what we had done last time, this is what we had ended on, was taking something that was in base whatever. We did specifically a base 2 problem and a base 12 problem. And we turned that base 2 and that base 12 into base 10. And we did it by expanding the values based on that base. So if we're in base 2, we have an expansion of 2's. If we're in base 12, it's the expansion around the number 12, where 12 is the base of an exponent. What we're going to do next, though, is we're going to go in reverse. We're going to take something that's in base 10, our base system, and we're going to put it into another base system. So here's what I want you to think about. Okay, let's think about I came into the classroom, and I have a basket of crayons. Okay, and I dump the crayons on the floor. That's like my base 10 number. It's just all the numbers of crayons on the floor, whatever it is. So when we're looking at our examples here, I've got 1,128 crayons on the floor. Okay, everybody good so far? You can picture this happening, right? It would be a mess, and we would all go, because we'd know somebody has to clean that up. Okay? Well, what we're going to do is we're going to put them into containers that are base 4 containers. Okay? So let's take a look at our place values inside of base 4. We always start with the units place, which is a ones place. And if it's base 4, what is the next place over's value? 4. Very good, Tasha. What would the next place over be worth? 4 squared. And then I would have 4 cubed. Let's do one more. 4 to the 4th. Now, we need to know what those numbers are, though. Otherwise, we don't know when to stop. Okay, so the first one's easy enough. It's 1. And then I have 4. And then I have 16. What comes after 16? What's the next biggest value? 64. And then what's after 64? 256. Is that right? Okay, so I'm still not really very close to 11,000. Agreed? So let's do the next one. What would the next one be? 1,024. Okay, let's go again. 4 to the 6th. 4,096. Just for kicks and giggles, go ahead and do 4 to the 7th. What's that one? 16,384. Okay, and that's too big, right? How do I know? It was 16,000 what? 384. How do I know that one's too big? What is it that says this is too big? Yeah, it's just that it's bigger than the number that I'm working with. That's all that it matters. Okay, if it's gotten too large for the number that I'm working with, I don't need it. Whoops. This is what I meant to click on. Let's try that again. I don't need that big. I just need the powers of 4. Which one are you looking at, girls?
4 to the 6. What did that say?
4 to the 6, 4,096. 4096. Sorry, I was trying to cram it into a little amount of space before I moved it. 4,096. Okay. These values right here, there's 7 of them, are the values that I'm going to use in a division scaffolding. That's what step 2 is, use the division scaffold. And that's the scaffolding that I showed you when we were working with the other numeration systems. So it's going to look and feel a lot like something we've already done. So we're going to take the value we're starting with, which was 11,028, and we're going to put it under that top hat. And the value that's the biggest one is going to go on the outside. So this is 4,000, 96. You're going to grab your calculator and you're going to divide 11,028 divide by 4,096. And what is the whole number part of that? 2. Now let me pause for a second and just make a comment that's really important for you to be aware of. What digits are possible to get in that location right there? Obviously we got a 2. What else could we have got? 0, 1, 2, or 3. There's no other number I can get there. Why? Because I'm in base 4. So if you're working and you end up with a digit that's not 0, 1, 2, or 3 because you're in base 4, you know there's an error somewhere. Maybe the error is that the 16,000 number was what we were supposed to start with, and you just did not keep going high enough to recognize I need a bigger value to divide by. That may be it. Or you may inadvertently skip something along the way and divide by something that wasn't in order the division you were supposed to make. But please be aware as you're working, the numbers that you're getting out of the division have to be within the base you're working in, or you have made a mistake somewhere. Okay? So, what do I get then when I do 2 times 4,096?
8,192.
Okay, is everybody getting that one? Same number? Good. All right, so someone else, tell me what you get when you subtract that. 2,800 what? 36, thank you. All right, so there is 4,098, or I'm sorry, 4,096. We already divided by that one. And we are going to go down in order. We did this one, and we're going to go to the 1,024. And there may be a time when we go to one that we really don't quote unquote need, but we do need it. So we're going to do them in order. All right, so what happens if I divide this by 1,024? It's 2 again, right? Yes? All right, what is 2 times 1,024?
2,048.
Fabulous. Maybe you did that one in your head. Did anybody do that one in their head? Those numbers were a little smaller. All right, we need to do a subtraction now. 2,836 minus 2,048. 788. Awesome. Does everybody else have a 788 on that one?
Yeah.
Great. All right, what am I going to divide by next? 256. Excuse me. All right, how many times will 256 go into 788? Oh, we get another number that's not a 2. All right, what is 3 times 256? 7 what? 60. 60? 68. All right. And if we subtract, what does that give us? 20. I'm kind of running out of space, so I'm just going to pick my picture up and move it over here, so to speak. Here's my 20. It's really sloppier over there. My goodness. All right. What am I going to divide by next? 64. And I know that feels awkward, but we do need to divide by the 64. It's not a very exciting division. How many times does 64 go into 20? Yeah, 0, right? It doesn't. It's too big. 64 does not go into 20, and it's totally reasonable to get a 0 on the outside. If we skip over that and we go to the division by the 16, we are going to be missing a 0 in our expansion of numbers, right? And I'll guarantee that if somebody owed you $2,022, you don't want them to give you $222 and just not give you that 0, right? The zeros matter. They matter here too. So we don't have anything to actually subtract. We're just going to keep moving along, and now we're to the 16. So how many times will 16 go into 20? 1 time. If I multiply, I get 16. I subtract, I get 4. What do I divide by next? 4. And this goes in exactly 1 time, and I subtract. And this is going to feel equally awkward here in a moment. It is a 0, and you can't stop soon. I mean, you can't stop too soon. You have to divide by all of the powers, which means my last step is to divide by 1, and of course 1 goes into 0 times. But again, that's that placeholder that I need right there. So here's the cool thing about the division scaffolding with base values. This right here is the answer in order from left to right. My answer in base 4 is that this number is 2230110 base 4. And we do need that subscript of 4 next to it. And if we don't skip anything, then it works out with the zeros in the right places. Okay, let's think for a second. If you wanted to verify that this is really the right answer, what would you have to do? Go ahead and tell me, Jamie, what would you do?
You would plug it back into how you started.
Yeah, we would do it like we did the last problems last time, right? We could say and take a look and say, oh, look, that 2 is in the 4 to the 6th place, so I could take 2 times 4 to the 6th. And the next 2 is in the 4 to the 5th place, and I could take 2 times 4 to the 5th. And I could go all the way down and add them back up, and if I did it correctly, I would end up with 11,028 when I'm done, right? So you can check to see that you actually got the right answer pretty easily. Here's something else that I want you to observe. Take a look at the original value, 11028. How many numbers is it? 5. It's 5 digits long, right? Okay. It's a base 10 number, and it's 5 digits long. I turned it into a base 4 number, and how many digits did I get? 7. And the key is that I got more than I had before. If I didn't have the little subscript that says 4 next to it, and you just looked at the 11028 and the 2230110, it looks like it's a longer, bigger, quote-unquote number, right? You with me? That always happens. When you turn something into a smaller base, the digits get longer. And when you turn something into a larger base, the digits get smaller, fewer digits. Okay? So that's a good sort of thing when you're looking at it at the end and saying, does this make sense? And if when I got at the end I had a 4-digit number, the answer would be no, it doesn't make sense. I screwed something up because I only got a 4-digit number. I should be getting more digits than I had when I originally started, and I'm getting fewer. So it's a good check step to think through when you're getting to the end of the problem. All right, we're going to do another one of these. Is this one okay before I move on to the second one? Okay. We have 99999 to base 9. Because, of course, there are no 9s in base 9, so this is definitely not already in base 9. All right, so what I need, though, is I need to actually figure out what my powers of 9 are, right? All right, so I know I've got the 1s place and I've got the 9s place, and you probably know 9 squared is 81. After that, your calculator might be more useful. So what do you get after 81 when you're doing powers of 9? 729. And then multiply that by 9, and what do you get? 65 what? 61. Okay, so that's still like 6,000, and I've got 99,000. So let's try one more bigger, see what happens. What's the next one? 59,049. Now, you can do one bigger if you want to just confirm it, but this definitely has to be big enough because 59,000 is only going to go into 99,000 one time anyway, right? This definitely is large enough value. This is where I could stop. So we're going to do the division scaffolding with this. I want you to take about 2 minutes to get as far as you think you can. We'll check and make sure that you're getting the same thing that I'm getting so that we make sure that we all have it together. So take just about 2 minutes and give it a try. Okay, most of you look like you're finished up to the point that I think we can at least start, okay? If you're still working, that's fine. Just keep checking in with us. All right, so the first step that you did looked like division with the 59,000, right? And I made mention already just a moment ago that this only goes in one time. Yeah? And you did minus 59,049. What was the remainder you got? 40,000. How much? 950. Big number still left, isn't there? All right, so then we have, what are we dividing by? 6561. How many times did that go in? 6. Quite a few times. So what was 6 times 6561? 31 what?
39, 36.
Did I get that written down right, Jamie? 6. Ah, all right. All right. And we subtract, what do we get? 1584. Let's see, what are we dividing by next? 729. How many times does 729 go in? 2. And 729 times 2 is what?
1458.
1458. We're nearing the end. That subtraction gives me 126. And what am I going to divide by next, Tasha? 81 is right. So how many times will 81 go into 126? Once, indeed. And if I subtract, what do I get? 45. My last, well, this is my last real division, right? It's going to divide by 9. I'm going to get it going in 5 times. Okay, did anyone stop right there? Did everybody do that last step? Got to remember that last step. We do want the division by the number 1. It does give me a 0 on the outside. I know it's not very exciting or interesting, but that place value, as we have seen in other people's numeration systems, is an important feature. So we've got 162150 base 9. Take a look. Did it work? Do I actually have a value that looks bigger in numbers of digits than the one I started with? I did, and I only went down 1 place value, right? I was doing place values in base 10, and this is in base 9, and I still ended up with something that looks larger than it was before. All right, I have one more example. It's not in your notes. This one is actually a real-life example. I was in Kohl's, and I saw this t-shirt for real. And that is a what? That is a Roman numeral. So we're going to try and figure out why in the world there is a Roman numeral on a shirt inside of Kohl's, because that seems like a strange thing, doesn't it? Why would somebody buy a shirt with a Roman numeral on it? So we're going to figure out what Roman numeral this is. So this one says MCMXCVIII. All right, so somebody tell me what's going on. We talked about these Roman numerals last time. MCM, well, how do I have 2 M's with a C sandwiched in between? What is going on here? Okay, so the fact that there's a C sandwiched in here is one clue. We can also think about the values that each of these are. What is the value of M? 1,000. What's the value of C? 100. There's another M that's 1,000. What's X? 10. What's C? 100. What is the V? 5. And then at the end I have 3. I'll group them all together. All right, so I've got 1,000, I've got 100, I've got 1,000, I've got a 10, I've got 100, I've got a 5, I've got a 3. The order of that's not especially friendly. I mean, there's something that's interesting going on, right? They're changing it isn't in decreasing order, in other words, right? So in particular, we'll do the first one right here. This place value right here, or this piece right here, has a smaller value in front of a larger one, and that's not, quote unquote, appropriate unless we're doing what here? Subtracting. So we're going to subtract that. So I've got the 1,000 from the beginning. And if I've got the 100 followed by the 1,000, that means I've got how much? Sorry, I left my 0 off. Let me try that again. I've got the 100 followed by the 1,000. So what's that value? That is 900. Okay? Take a look at the next one then. I've got a 10 followed by a 100. What's that? That would be 90. And then what happens at the end? They're in order, right? 5 and then 3, which would give me, it would give me an 8. So what is this value? So speculate with me. Why do you think that this value, what might it be representing on this particular shirt? Probably a year, right? What year were you guys born in? 96? 95? I'm guessing that this is probably someone who's graduating this year. 98?
My brother's born then and he's graduating.
Yeah, 1998. This is probably why this particular date is on here, but it's interesting. So you see, I thought it was fun to see this in Kohl's, so I had to show you. All right.